What's going on, guys? In this video we are going to see how to solve a boundary value problem. Here we have general solution of a differential equation is provided, and the question is asking to find the particular solution, and also we have two initial conditions. Now let's go ahead and apply this initial condition and see what we get. First we have y of 0 is equal to 1, so this means when x is equal to 0, y is equal to 1. So this is our x value and this is our y value. All we have to do is just plug it in this equation. So this is going to be y of 0 is equal to 1, so this y value is equal to 1, right? And then we have c1 cos 2x, so cos 2 times 0, that's going to be just 0, right? Cos 0, and then plus c2 sine 2 times 0, that's going to be 0. So this is sine 0 cos 0, and we know that sine 0 is 0, so we can get rid of this part right here. This is 0, and cos 0 is 1. So 1 means this c1 is going to be equal to 1, right? Because c1 times 1, that's going to be c1. Therefore c1 is equal to 1. This is our first value, c1. And to find c2, what we have to do is we have to write, plugging in this c1 value and write this equation again. So this is going to be y of x. We know that c1 is equal to 1, and therefore 1 time cos 2x, that's going to be just cos 2x plus c2 sine 2x. So this is the equation we have when we plug it in this value. Now we have to find c2 sine 2x. So to find this one, what we can do is we can find the derivative of this one and apply this second initial condition. So if I find the derivative of this one, so y prime of x is going to be derivative of cos 2x. Cos x is minus sine x, so this is going to be minus sine 2x, and also this is going to be chain rule, right? So this is going to be minus sine 2x, and the inside derivative is going to be 2. So this is going to be multiplied by 2 plus, then this is going to be c2 cos 2x, and the inside derivative is 2 again. So this is going to be 2 c2 cos 2x. Now let's write this one in better way. So this is going to be minus 2 sine 2x, and okay, let's write this one first and then plug it in. So minus 2 sine 2x, and this is going to be 2c2 cos 2x. Okay, now we have this one, so we are going to use this initial condition and plug it in right here. So we know that here that's y prime of 5 by 2. 5 by 2 is equal to 2. So this means when x is equal to 5 by 2, y is equal to 2. So this is our x value, this is our y value. Now let's continue this one right here. Okay, so we have y prime of x. So y prime of 5 by 2, we know that 2. So let's plug 2 for this y prime, and 2 is equal to minus 2 sine 2x. So this is y prime of x is equal to this one, minus 2 sine 2x, minus 2 sine 2x. So for x value we are taking 5 by 2, right? So 5 by 2 times 2, that's going to be just 5. So this is going to be 5 plus 2 times c2, and cos 2x again 2 times 5 by 2, that's going to be 5. So this is going to be cos 5, right? And sine phi is 0. So this whole thing is going to be 0. This whole thing is going to be 0, right? So this is the only thing that's going to remain. So let's write that one. 2 is equal to 2c2, and cos phi is equal to negative 1. So this is going to be negative 1 right here, and therefore negative 2c2 is equal to 2. Therefore c2 is going to be equal to negative 1. Now we have the c2 and c1, so we can write our particular solution. So the final answer of this one is going to be y of x is equal to c1, and we shouldn't write c1, we know the c1 already. C1 is 1, right? C1 is 1, so we plug it in this equation. So this is going to be just cos 2x right here, and c2 we know that is minus 1, so this is going to be minus sine 2x, and that's it. This is going to be our particular solution for this general solution, or you can say particular solution for this differential equation. We don't have differential equation given, but right, so this is the particular solution, and that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.